And let's just... Okay, so the first problem gives us, it was let's see. It says given x of y. Okay, so do you want to tell me what this notation means?
X of y? Like, I don't know.
Okay, that's okay. Don't worry about it. So this means that x here is the dependent variable. And y is independent. So basically, usually, let's say I have a line. Let's say my line is y is equal to 2x plus 1, right? I can plug in random values for x to get my y, right? But now, because they flipped around and now my x, oh, what's happening? Now my x is my independent, now my x is my dependent variable. So now it's x is equal to 2y plus 1. Do you see what I'm saying?
Yeah, I got it.
Yeah. So this is all that means. So now this actually also affects our derivative. Because look at the denominator. It's dy, right? Oh, it's dy, right? Usually we have dy dx, but this time we have dx dy, which means that we no longer wait, do you guys put the prime? Like, do you guys do like y prime when you're taking the derivative of something?
I think he wants us to, but in the answers he doesn't put it.
Yeah, he changes them back into dx dy.
Yeah.
Okay, that sounds good. We can do it that way then. So let's say 9 is number 9 says that we have x squared is equal to sine squared y, right? And it wants us to find dx dy. Okay, so first of all, let's start with the obvious. We're gonna have to take both the derivative of both sides, correct? Yeah.
So you put both of those sides in like the derivative?
Yes, so basically imagine them as if each one is like a different function for a little bit, and then take the derivative of the first one and then the derivative of the second one. You know, it's like they're two different functions.
Okay.
And then set them equal to each other. Okay, so first of all, we're doing basically d of x squared, correct? Over dy.
Oh.
And
because
then
what I had put was 2x.
You're right. It is. It's gonna be 2x later. However, you forgot. You would have forgotten one thing. Is that it's not just 2x. It's 2x times x prime.
Okay.
Yeah. So because you always look at the denominator. If you're taking the derivative with respect to y, so whatever the other variable is, when you're taking the derivative of the other variable, you just add that variable prime. So because we're not taking the derivative with respect to x, we're taking it with respect to y. So it'll be the derivative of x squared times x prime, basically. You want to know the reason behind why we do that?
To put the dx over dy?
Yeah, you want to know the reason why we add the x prime to that? Or the dx over dy?
Yeah, why?
So basically, I can't take the derivative of this. This thing does not make sense. Because I can't take the derivative of dx and dy is like, you know, like there is no y in the function. So I can't just do that. But what I can do is I can multiply this function, by dx over dx. It looks like I'm multiplying by 1, right? Because they can cancel out or whatever. So let's look here. Let's look at the pink. If it's dx squared over dx, what would that give me? Wouldn't that be the derivative that I can take? I can take that derivative. This derivative makes sense, right? Because it's x on the bottom and I'm taking a function of x on top.
Yeah.
So now I'm left with something. I am left with these guys right here. So I am now left with dx over dy. So this one here gives me 2x. And this one here gives me x prime. This guy here. And that's how this came from. Like, this is how this thing is solved.
Oh, okay.
So now we know that. Let's take the derivative of the other side. What would the other side be?
Is it like the chain rule?
Yes. So let's start it. How would you start this chain rule?
So I have it in my notes, like it would be cosine u times the derivative of u.
Exactly. But first of all, you have to notice that there is
The square. Yeah.
you have the squared, right? So this square gets dropped down first. So it becomes 2, and then we keep just sine of y intact. Right?
Okay.
Times, so let's write this in a different way actually before we proceed so that you know what it's going to be times what. So sine squared y is basically just us saying we have sine y squared, right?
Yeah.
So we took the derivative of this one, we dropped it, and then we subtracted 1 to get 2 sine y. But there's one thing we haven't done. We still need to take the derivative of this guy. So it's going to be multiplied by cosine of y.
So the cosine y comes from the
sine, the derivative of this guy, derivative of sine.
Okay.
It's a chain rule, you're right. It definitely is. So now let's write it again. We know that we have 2x times x prime is equal to 2 sine y cosine y. Do you recognize this? Because this looks really familiar, don't you think?
Yeah, isn't that I don't know, doesn't it equal sine 2?
Exactly, it's the double angle identity.
Double angle, that's what it's called. Okay.
So from this guy, I know that 2x times x prime is equal to sine 2y. You are definitely right. It is a double angle identity.
Yeah, that one keeps popping up.
It's actually really helpful to just memorize most of your identities because they're all gonna pop up a lot of the time when you're doing, especially with implicit differentiation. So now, okay, I just need my x prime because all I'm trying to solve for is the derivative, right? So I just need this portion right here, this guy. So all I do is I can just divide by each side, 2x by each side. So these go away, and I'm left with x prime is equal to sine 2y over 2x. And remember, we said here that dx dy is just another way of saying x prime. So we know that dx over dy is equal to sine 2y over 2x. I think this is the answer. Can you please check with your
yeah
worksheet?
Number 9. Yeah, dx over dy equals sine 2y over 2x.
Perfect. We got it.
Yay.
Okay.
Yeah, I'm just rewriting it.
Okay. Okay, I'm just gonna pause it before we start the second one, okay?
Mm-hmm.